We have an iPhone 16 Pro charging epidemic. You might call it a charging catastrophe. So welcome to the iPhone 16 Pro ChargePocalypse. This chip is dead again. This is the third iPhone 16 Pro charging video I'm making, and that's because the requests are piling up. This iPhone died completely after some charging failure, and this is starting to look like a major problem and design flaw. This is the 16 Pro motherboard and it's been pulled out of this housing. Hi, this is Aaron with iBoard Repair, and today I'll be working on another iPhone 16 Pro that has died after some bad charging incident. And this is becoming so frequent and I'm getting so many requests for these that it's starting to look like a signature issue, the likes we haven't seen of since the olden days. There's a lot of dead iPhone 16 Pros and they're dying because some charging problem occurred and it's either not allowing the phone to charge anymore or it's outright killing the phone, as we're seeing in this case here. What you just saw me doing was injecting voltage into the battery connector, and that voltage has leaked into the charging IC, disrupting the normal power sequence and killing the device, and we're seeing the chip heat up as a result. Sometimes it's only the one chip that's damaged, but I've seen as many as 4 different chips damaged from charging incidents, always including this one. Let's take a look under the scope and see what we can find. So it's basically always this chip. On the thermal cam, we saw heat somewhere in this vicinity of this chip. And all I'm going to do now is take it off. I'll check to see if it clears. I'll check the lines underneath it to make sure there's not a different power rail that's still going to be affecting it afterwards. And a lot of the times, that's all that's needed. I was directly injecting into this point here, and this chip actually connects these two different points. So while this chip is off, it's also useful to check to make sure the short is gone on both sides of these test points here. Let's go ahead and remove the chip. I'll go ahead and flatten these pads now while the board is still hot. It's the easiest time to do it. Here's the 16 Pro board view, and I'm going to do a quick check of the values at the pads underneath the chip to make sure none of its power rails or any of these other lines are short at a different spot other than the chip itself. For example, if this capacitor is short, it's possible we can see heat show up at the chip when injecting over here into, this is BAT VCC BPIC or VDD main. Before I check those values, I'll just check to make sure that that voltage leak is now gone. I was injecting right here when I was showing the thermal cam. And once I touch ground, if we have no amperage draw, then the leak is clear on this side. And we have no amperage draw. I'm looking right here for reference. But it is also worth it to check on this side, because if the leak originated on this side with the chip removed, it might not show up on this side. So let's just double check that. And we still see no amperage draw. So that voltage leak is officially gone, but it's still worth it to check the pads underneath the chip itself, because if one of those lines is short, it could show up here again once the chip is put back down. So just as a precaution and to save yourself soldering, it's worth it to just check values real quick. In this case, I'm not necessarily going to check for exact values. I'm just checking to see if there's a full short on any of the lines that shouldn't have it. So I'll turn my multimeter on. Looking at the board view, I don't have much ground here underneath this chip. It's mainly this top line with this excluded, and then these two, and then the bottom line with this one excluded, and then these two again. And then one more, 1, 2, 3, 4, right here. And nowhere else should be ground. So I'm just going to quickly scan these and see if any of them give me a ground reading when it shouldn't. And as long as none of them do, then I know that I can just replace that chip and we're probably going to be good to go. Also, I can see when the pads are connected just by looking at the motherboard, so I don't necessarily have to check every single one if I see they're on the same path. Here, for example, I can see it goes all the way through there. They're all the same line. And then here, those are all the same as well. And that all seems to measure okay. So in this case, this is one of the simpler examples of this problem. It's only this chip, it appears. And when it's only the chip on the surface layer of the board, then even though this is only a data recovery customer, this customer will get back a fully working device without any additional costs. Because what I have to do to pull the data is the same as what needs to be done for this motherboard to work normally. I'm very lucky I don't have to split the layers and get to the more internal guts of the phone, and the problem is lying on the surface layer and can be fully resolved on the surface layer. So I'll find another chip, we can replace it, and then we can test this again, and this should be a quick job. I don't have any new chips left, so I'll pull this from a donor board. With the chip pulled, I'll clean it up and reball it. Let's get the chip onto here. Okay, I do believe the issue should be fixed. And let's test first to make sure there's no more amperage draw at the battery connector or main. So I'll touch my probes to ground and to, this is VDD BAT BPIC, I believe. No amp draw, good. No amp draw on main, good. So this is most likely working. Let's just go ahead and put it into the housing and see if it turns on. I guess before I do that, we can just test with the DC power supply to see if it looks like it's booting. So that's probably worth it to try. I'll touch my probes to the battery connector here. And then by shorting these two pads, this can act as a button press, a power button press. And that looks normal enough. Let's go ahead and put it in the housing. I do think it's fixed. So I've got it roughly put together. Let's see what happens when I plug in the USB-C charging cable. And it may show the low battery symbol. It may turn on. Let's see. Low battery symbol. So that's good. This isn't actually an ammeter. Let's check the ammeter and make sure it's actually charging. It doesn't appear to be charging normally. It's cycling charging. When I've seen this cycle, it usually means the charging controller or charging logic chip is also dead. I was kind of hoping this one would be simple, but it does go to show how problematic these charging issues are on these iPhone 16 series. I'll take it back out of the housing and we can take a further look. I've got some new parts plugged in so we can get a good test. Plugging in the USB-C charger does prompt it to boot, and we do see the Apple logo. But if we look at the ammeter, we have 0 amp draw on here. Let's see if the phone thinks it's charging or not. It is fully booting up. So the catastrophic fault has been addressed, but it's still not charging normally. And with the battery that came included with this phone, it wouldn't turn on because it won't charge. But with a good battery, it will turn on. And it thinks it's charging, but we're getting no amperage draw from the charge port, so it's not actually charging. If I unplug the charge port, we do see the green symbol turn to white, and if I plug it back in, it says it's charging, but again, there's no amperage draw, so it is not. This is called false charging, where the phone thinks it's charging, but it's not receiving any charge. If I were to plug this into my computer, it cycles on and off. The computer sees it and then it disconnects immediately. I've seen many symptoms of these charging ICs dying. The first charging chip that we changed, it's pretty typical. It will kill the entire phone, but it doesn't necessarily have to, and it can still be bad. This symptom that we're seeing here is much more typical of the other charging IC, the charging logic IC, the charging controller. When that one goes bad, typically the phone will still boot most of the time, but you'll see these odd issues as in false charging, or the charging symbol flashing on and off, or connecting and disconnecting from your PC when you try to connect it. So let's pull this back apart and work on the last chip. I did get some information that may be relevant, so let's talk about that. Here is the other charging chip that is most likely causing the issue that we're seeing now. And my friend Jesse Cruz with VCC Board Repair, who I also believe is either just released or will be releasing a 16 Pro charging video as well. He told me I may not need to change the paired ROM chip in order to fix this issue. He said just try changing this chip itself, the controller, and a lot of the times he's seeing that work perfectly fine. So I'm going to try that. I have a fresh chip that I've bought in. And I don't know if it makes a difference whether or not it's a fresh chip or whether it's pulled from a donor board. In any case, I'll go ahead and pull this off and let's see if we can get it working. And the huge benefit of not having to change the paired chip is that we don't have to split the layers again, which is always the biggest hassle when you're dealing with an iPhone, is splitting and reworking the layers. There's also a programmer that's supposed to work, but I've heard people having some trouble with it, and I just don't have it either way. Let's get this soldered to the board and see if it works. Looks pretty good. Let's clean it up and test it out again. I'll be pretty happy if I don't have to change the other chip. Okay, with just a battery and a charge port plugged in without it fully connected, we are getting amp draw from the ammeter. So this should be good. Let's just put this into the housing. The phone is on and working and is charged from 0 to 87%. And if I plug in a charger now, it tries to connect and it stays connected, but this one has stolen device protection, so it will not. But it does prove that it's fixed. And 3U tools can try to connect as well if it was able. So thanks to Cruz for providing that information that ACE, the charging ROM, is no longer paired to the charging IC. And according to a couple of other friends, this has been the case since the last major iOS update. And this is great news for repair. If we can change this frequently damaged chip without having to split the layers of the board, it makes repair a whole lot easier and feasible for this model. So I do think this major charging failure is very problematic on Apple's end, but at least I have an easier way of dealing with it now. Also, I still have a few other 16 series videos that are on the way. Unfortunately, my oldest are kind of my most impressive technically, but they're the least impressive in terms of video quality. I have an iPhone 16 Pro Max CPU swap, and I also have a RAM swap. And both of those are the oldest videos I have in this 16 series. So the oldest 16 series video you'd see on my channel, these videos are older than that. And the quality of them are a little bit less than what I have had recently. And that was because only recently I've really tried to make my video quality a little bit better. So I do have some impressive videos still. Aside from those, I have two water damaged iPhone 16 Pros in queue, and I plan on filming them, and hopefully one of them will give us an interesting enough story that we can make a video out of it. And aside from both of those, I've actually recently just done work on a MacBook Neo, which has the A18 Pro processor, which is the same that the 16 series uses. And on that video, I did all types of things. I did a storage upgrade using an iPhone NAND chip and transferred it onto the MacBook Neo. And then I tried to do a CPU swap, and a funny thing happened. The MacBook Neo was recognized as an iPhone when it was trying to do a DFU restore. So I have these videos on the way, so if you'd like to see them, make sure to subscribe, and I'll see you next time. Thanks, bye.